Then thermophysiological comfort properties, this is another important aspect, and here it gives you an association basically that this fabric comfort aspect, how it is related to fiber, yarn, fabric, makeup, environment, activity and wearer. We will just let us try to understand this particular slide. Comfort, thermophysiological comfort, sensory comfort, ergonomic comfort, that is mobility and dexterity, and psychological comfort. So, comfort has 4 aspects. Now, thermophysiological comfort, if we see, this comfort is actually connected to what? It is connected to fiber type, it is connected to yarn, fabric, makeup. It also depends on the environment, level of activity of the person and the wearer. So many things, almost everything is going to affect the thermophysiological comfort. So, when it comes to insulation, moisture absorption, water vapor permeability, all of them will have a role to play. So, the activity level of the person is also very, very important. So, that can also affect the level of the heat that a person generates when he is working. That is called metabolic heat generations. To some activity depends upon the level of activity of the person and also depends upon the wearer also. So, the environmental can also affect the amount of heat that will flow from the body to the environment per unit time. We will discuss about them in more details later on, but what we see here that all of them will have a role to play from thermophysiological comfort. Sensory comfort, that is related to feel and touch, depends upon fiber surface, cross-sectional shape, fabric surface characteristics, etc., and these are dependent upon these parameters. Depends upon fiber type mainly, it can also depend upon the fabric, and yarn can also affect some role on the sensory behavior or tactile comfort level. So, this particular slide is going to give you an idea that these comfort aspects are basically dependent on fiber, yarn, fabric, makeup. Some of them like let us say sensory effect is not dependent upon the level of activity of the wearer, it will not depend upon that. As you see, there is no connection between these two. Obviously, sensory or feel, touch does not depend on the activity or the type of wearer a person is, it does not depend upon the environment also. So, they will not have any effect on this. Sensory activity will depend upon the fiber that has been used, the type of yarn that you have used, and the fabric or maybe the finishing techniques, which is not listed here, but finishing process also could be play a role there. The ergonomics part mainly depends related to cut and fit and elasticity of the fabric. So, it will depend upon fiber type. See, this arrow is there, depends on the makeup, that is the size and the way the fabric has been converted into a particular uniform or a dress. Then it will also depend upon type of fiber, because there is a connection between this and this, depends on the yarn and depends on the fabric. So, here they will all play a role. Psychological comfort is basically subjective feel and good factor is there, that is somebody feels good and there is a feel good factor, you can say, very subjective in nature. It also depends on the fashion, the cut, styling, and these are all basically dependent on type of fiber that you have been used, the yarn and fabric. Because this orange arrow, if you look at it, this orange arrow is connected to fiber type, yarn and fabric. So, these are the things which will affect the psychological comfort of a person who is wearing a particular dress. So, therefore, this particular slide gives you an idea that there are 4 different types of comforts, and these comforts are affected by the parameters which are listed here. Out of this, if I little bit put more focus on wearing comfort, that is basically a kind of mobility related comfort, that is ergonomics basically. So, here this wearing comfort basically a function of again stretchiness of the garment that somebody is wearing, how light it is, the slippability, and also reduction in clinging to the skin. All of them are connecting to the wearing comfort. Also, we can add one more point, maybe prickliness also could be a part of wearing comfort. So, but prickliness is more of a sensation. So, that could be a part of tactile comfort. Here it is wearing, we are relating it more to mobility aspects, and therefore, these 1, 2, 3, 4 types of factors which have been stated here, and you see how these factors is a function of like stretchiness is a function of fiber parameters, yarn parameters, fabric parameter, finish and makeup. So, we are giving a list, each of them one has to think is it how it is connected to fiber parameters, if so what are the fiber parameters which will affect stretchiness. Then from fiber we should go to the yarn and think what yarn parameters will affect stretchiness or what fabric parameters will affect stretchiness, what finishing techniques can affect stretchiness. Stretchiness does not depend on the finishing techniques. So, therefore, you will see a nil or nothing, and it is also not dependent on the makeup. So, it is basically more dependent on the fiber parameters and then to some extent on the yarn and fabric. So, whenever a particular aspect or particular performance aspect of a fabric needs to be enhanced, one has to think that what are the relevant property for that particular performance aspect and how that property is going to be affected by fiber, yarn, fabric, finishing techniques or maybe makeup. He has to make a table and he has to keep writing. Okay. From there, if we go to the tactile comfort now. So, tactile comfort again you see is a function of shear of the fabric, bending rigidity, friction, softness and prickliness. Prickliness has come here. All these properties is connected to tactile comfort. And here in this table, we have written that how softness, friction, shear, bending properties are related to fiber parameters, yarn parameters, fabric parameter, finishing techniques and garment making or makeup. That means, if I want to change the tactile comfort, if there is a demand that this particular aspect needs to be looked into by a designer, because there is a demand from the customers, then these are the various options which are there. He has to find out whether the tactile comfort is due to the friction part of it. That is, somebody, if the customers are not happy with the tactile comfort, then what is the reason for it? Why it is not comfortable? Is it because the fabric is not soft? Is it because that there is some issue with the friction part or shear or bending properties? First, that needs to be identified, and once we identify them, then will come that if it is because of, let us say, friction, then we have to think that how the friction property can be changed. Is it because the friction is too high, or is it because the friction is too low? Whatever is the reason, we must be aware of the facts that how the friction of a product can be changed by fiber, yarn, fabric and finishing techniques. So that we know these are the options that we have, and we can play with all those options one by one to make a change in the tactile comfort part. I have taken another example for thermophysiological comfort, where microclimatic control is stated here. You see here the microclimatic control is dependent on warmness, reduction in sweaty humidity, waterproofness, water vapor permeability. So many attributes are there which are relevant to microclimate control, which is a part of thermophysiological comfort. And we see in this table how these functional attributes are connected to fiber parameters, yarn parameters, fabric parameters and garment makeup. So, you have to go through this slowly and see whether you can add something more to it or not. So, one has to, the thinking process should be that write about the functional attribute first and start thinking from fiber, that whether this particular attribute can be any way influenced by the fiber or not. Then come the yarn, then fabric, then garment makeup or finishing techniques. Point is, here you need a lot of your domain knowledge. That is, when we come to these aspects, then a very good understanding or a knowledge is what is required. And what is that knowledge? The knowledge is not how to manufacture only, the knowledge is how to relate a performance property with the fiber, yarn, fabric, finishing techniques or garment makeup. So, thorough understanding of the relationship is what is desired. That is will be very, very handy for a designer. Now, let us say qualitative relationship, that is yarn end density and finished good properties. If I try to represent a qualitative way, then another example is shown here, like certain fabric properties like tenacity, aerial density, crease resistance, how they are related to ends per inch. We all know that fabric constructional parameters ends per inch and peaks per inch, these two are very, very prominent parameters of fabric constructions. So, here how ends per inch is going to affect tenacity, aerial density and all these properties, that is what is stated here, ends per inch low and high. So, tenacity will be lower if the ends per inch is lower, seam strength will be low if the ends per inch is lower, water vapor permeability will be higher if ends per inch is low. When ends per inch is low, see ends per inch here it is low and this is high. When it is low, that means there is a lot of gaps between the yarns. So, vapor permeability is going to increase. Similarly, fabric quality, but is going to be poor if the ends per inch is low, because fabric will be look like too much of space if we create between the yarn, then the fabric will not be tight enough, fabric will not be stable. So, that kind of fabric will be poor in quality. So, the properties are also affected by finishing and particularly shrinkage process if it is made from cotton fabrics. And as you know that some this is a quantitative relationship we have already seen, which we have stated here. So, this is a quantitative relationship between fabric strength and yarn end density, the yarn count and yarn tenacity. This is a qualitative relationship. So, initially we should know the qualitative relationship between fabric property and fabric structural parameters. This is one structural parameter, that is ends per inch. There could be another structural parameter also, picks per inch could be there, the total number of interlacement per unit area also could be there, the cover factor could be there. These are the things that is could be there. So, initially and qualitative understanding which is required, followed by a quantitative relationship, if it is there, that can be used. Technical performance properties and their influencing factors. So, property tensile strength, tear strength, bursting strength, relevant fiber, relevant yarn, relevant fabric parameters are stated here. For the sake of this knowledge, we have listed them. This side is the property of the fabric and this side, the other column is relevant fiber or yarn or fabric parameters are all stated here. So, similarly, we have to do it for other types of fabric. This is basically for the woven fabric. We can have similar table for knitted fabrics, for non-woven fabrics and for maybe compound fabrics, for braided material. So, one can have this is the tables could be made. This is another example, fabric property for a technical fabric. See the properties, relevant properties for technical fabrics are initial strength, modulus, tearing strength, bending stiffness, air permeability, abrasion, shear, flexural. What we say, this is another way of representation only. What is the way? That here you see on the left hand side column we are writing the fiber, yarn, twist, threads per inch and interlacing per unit area. Only few parameters are listed and we are writing increase only, that if I increase this, what happens to the fabric property, and a 0 indicates no change and an upward arrow means it is going to increase and a downward arrow means is that property is going to decrease. So, this is also a kind of representation of relating fabric property with certain parameters which are relevant to that, and also at the same time not only giving a list, but by having this arrow and its upward and downward arrow indicates that whether the property is going to rise or going to decrease when if we increase these parameters. Let us take an example, and this is another one, that is u, that is inverted u. This indicates that it is going to increase first and then decrease. Like suppose yarn twist, if we increase yarn twist, because here there is an increase only, when yarn twist is increased, tensile strength of the fabric is going to increase first and then decreased. It will go up first and then come down. So, it is a inverted u is written here. The modulus is going to decline with increase in twist. So, the arrow is downward. Tearing strength 0 means no effect. Bending stiffness is going to increase, the fabric is going to be stiffer. So, like that, this is a way of representing the relationship in terms of, you can say this is a visual effect of the relationship. Instead of writing in text format, we are basically using some symbols, upward arrow, downward arrow, 0 or u could be inverted u or it could be U. In some cases this may also happen that we have just U. There is no example here where it is U, but it is all whatever I see here, this is all inverted U, and it is going to increase first and then decrease. So, such kind of table has been used by some researchers, and they are also very handy. Fabric aesthetics, if we come, another important aspect where clean appearance, attractive color, folds, luster, all of them actually is a part of aesthetics. And let us look at one only aspect, fabric luster. Now, if luster is an issue with some company, and as a designer you have been asked to look into it, that the how to make the fabric more lustrous. So, you must know that fabric luster, you should make a diagram something like this, like we write finishing, then fabric, then yarn, then fiber, and you are again writing like in the finishing, what processes of finishings can affect fabric lusters, these are stated here. Then what part fabric property or fabric parameter will affect fabric luster, they are also stated here. Then we come to yarn, fabrics are made of yarn. So, hierarchically we are going down, what parameters of the yarn will affect fabric lusters, what parameters of the fibers will affect fabric luster. So, again this is a visual representation just to say that these are the stages in the or these are the various relevant parameters of finishing, fabric, yarn and fiber, which will have a bearing on the luster part of the fabrics. So, if we have this knowledge with us, now the designer will be able to opt for the right solutions, because he knows that there are so many solutions available with him. He can play with fiber, yarn, fabric, finishing techniques, and based upon cost considerations, as I said, based upon availability of the technology, one can choose the one that suits any given circumstances. Another problematic situations is peeling propensity is also many a times many of the fabrics are rejected just because it is forming a lot of peels. So, that is another typical problem we face with many fabrics. So, an idea that if that has to be tackled, then a general studies research is required in many circumstances, it will be required by the designer or designing team. Then let us study it as to understand how peels gets formed, and there are many research articles from which can be studied as to have an idea. So, that is the background research that one needs to do while trying to design also. So, we call it design research, that is we are doing the research for the sake of improving certain performance. So, if it is the case of peeling, then the mechanism of peeling has been stated, where it is because of entanglement of projecting hairs on the fabric surface, which refuses to shed off. These are two things. One is there has to be an availability of fibers, projecting out fibers from the fabric surface. Next stage is these projecting out fibers would get entangled by some means. And the third thing is after entanglement, these are not going to shed off. So, that is strong enough to remain stuck to the surface of the fabric. So, this has been studied by many people. So, we have only stated that this is the mechanism in very short, and here again as if this is the result of the design research. So, for a given design, the designing team or the designer himself has to do some research, and that research is related to studying some research published article or reading something from the textbooks, and then he makes an abstract of that, and this particular diagram is as if it is an abstract of that, and it remains in front of the designer, so that he can easily visualize that peeling resistance occur when, with respect to fiber, the fiber properties are listed here, yarn properties, fabric and finishing. So, when this friction property of the fiber is high, then peeling resistance will improve, that is, the fiber will not be able to move out from the fabric surface easily. That is why, so relevant fiber properties are listed, then yarn properties, fabric property, finishing techniques, and this side we are writing peeling resistance occur when high or low, that way we are stating here. So, if we say peeling resistance will occur, that is more resistance will be there if the fineness of the fiber is high. That means, if I make the fiber coarser, the resistance is going to increase, because fiber is not going to bend so easily, and therefore, they are not going to get entangled so easily. So, finer fibers, we can expect them that they will form peels very easily, because their bending rigidity is less, and therefore, they can easily buckle, bend, and therefore, neighboring fibers can get entangled. So, this is how you can, in a way you can say, this is the gist of a design research, where a designer finally is writing that how peeling resistance can be improved by manipulating or by changing fiber parameters, yarn parameters, fabric parameters, finishing parameters. So, it is not only a list of parameters, but also stating that how these parameters are going to increase or decrease. If I want to peeling resistance, I want to increase, then what I should do with these parameters. So, it is not only listing, but also stating in a way that what will happen if these properties are changed. So, there is different way of representations. So, reasons for peeling is stated here, and we see if we do a design study, a research, then these are the various reasons: presence of projecting fiber ends, ease of entanglement, ease of plucking, high bending and torsional rigidity of fibers, and high tenacity and breaking energy of fibers. These are the various causes of peeling. So, solution options are given here, and one can write what are the various solution options, and then he can choose, or he or she can choose which option to be adopted in a given situation. So, projecting fibers is a source of entanglement. So, you have to see that this should be minimized. So, if I want to minimize it, then I must know, okay, what can I do with fiber, whether fiber can play a role in minimizing the projecting fiber ends. So, that will need a domain knowledge or a study. Yarn, use of compact yarn is a solution given here. Singeing is another process by which I can reduce the projecting hairs. So, we can think of writing, making table like this, and from this table we can find out what are the reasons for a particular performance related parameters of the fabric, or for the maybe for the design products also, because whatever we see in the fabric, same thing also is visible in the design products, which could be a garment many times, or in some situation it may not be garment, but there are a lot of technical use of the textile products also, where it is not a garment. But peeling is somehow very related to the garment that we use regularly, and this is a very typical problem that we face. With this, we close this particular lecture, where you have got an idea. It is very essential for a designer to know what are the various performance parameters, how these performance parameters are connected to fabric properties, and then how these fabric properties are related to yarn, fiber, different parameters and their properties. This understanding is important. One has to do the research related to designing also, because sometimes these answers may not be available directly, and one has to make some background research to understand this. And wherever there are some mathematical relationships are available, we will try to make use of them, because sometimes manufacturing a product and then testing is, and then trying to find out whether it suits or not, is a basically trial and error type of approach. That approach we should try to avoid, and we should be more and more objective in our approach, where we will try to use the scientific methods, the scientific tools which are there, and in some situation we will use lot of softwares also, we can make use of them. We can use Microsoft Excel sheets to do some calculations. We can use MATLAB for the calculation, necessary calculations. So, there are a lot of tools which are available nowadays, that computers are there. So, calculation part has become relatively easy. There is no need of go through the manual calculation mode now, and we can see the effect also by plotting necessary graphs, and then the entire design process can move forward. And so, once we are satisfied with the design parameters and finalize it, we actually go for then productions and make a prototype and then go for testings. Okay. With this, we close this session. Thank you.